Consider the linear system of 5a plus 2b equals 5 and 2a plus 3b minus 13 equals 0. To solve this, you need to consider which method to use. You have an option of substitution, elimination, or using graphing method. In this case, elimination will look to be the fastest. I'm going to call this first equation 1. And this second equation, I'm going to move the 13 to the other side and call it 2. My goal here now is to eliminate a variable. I can eliminate A or I can eliminate B. Today I'm choosing A. I'm going to create a third equation. It's going to be equal to my first equation times 2. That gives me 10a plus 4b equals 10. I've multiplied each term by 2. My fourth equation here is going to be given by 5 times my second equation. I've done this so that my coefficient in front of a is the same. So 5 times 2a gives me 10a. 5 times 3b gives me 15b. And 5 times 13 gives me 65. This is great because now I can go my equation 4 minus my equation 3. So if I could, you don't have to do this, but what I can do is write this in fully out. You get 10a plus 15b minus 10a plus 4b equals 65 minus 10. Okay. You can write that all out, and then you can look at your 10s together, or your a's together, and then your b's together, and then as you can see here, this is what you're doing in your mind. So without showing all this work, because that takes up a lot of space, I'll just go 10a minus 10a gives me 0a. And then I go 15b minus 4b gives me 11b. And then I go 65 minus 10 is going to give me 55. I can now solve for b, which gives me 5. I'm going to use that to help me find a. I can substitute b equals 5 into either equation 1 or equation 2 to find a. Let's use equation 2 for fun. All right, so we have 2a plus 3 times my 5 I found equals 13. So 2a equals 13 minus 15 gives me negative 2, so I get a equals negative 1. All right. Now I want to check these answers. I'm not certain if I'm right. So let's check. In 1. We use equation 2 to find a, so let's check in 1. So we got 5 times minus 1 plus 2 times 5 equals 5. Let's make sure our left side equals our right side. So we have minus 5 plus 10. That gives me minus 5 plus 10 gives me 5. So very nice, my left side equals my right side, so that tells me I satisfy this equation. So therefore, my point of intersection, if I were to draw these two lines, is at a point AB, if I choose A to be my independent variable and B to be my dependent variable, -1, 5. So there's my solution. So because I chose A to be my independent variable, it goes here, where otherwise we usually put X. And then B would go here. That's the dependent variable, and that's usually where we have Y. And let's set each unit to be 1. So this will be 6, this will be 6, this will be -6, this will be -6. All right. Let's carry on and get our A and B intercepts for 1. For my A intercept, I let B equals 0. This gives me 5A plus 2 times 0 equals 5, and I get an answer of 1. For B intercept, I let A equals 0, and this time I get 2B equals 5, which gives me 5 over 2, which is 2.5, and I can now write down my intercepts and draw my line. Decent estimate. Now, we're going to do this in our head now. We're going to do it for equation 2. I get, for my B intercept, 4.33. Let's make this red. And my A intercept is going to be 13 over 2. So that takes me over here at about 6.5. And I'm going to do my best to draw a straight line. Let's take one more run at it. Pretty good. And you'll see here that we get intercept at -1, 5, which is consistent with what we did for elimination. Let's carry on to another example. Here we have a system x minus y equals 5, y equals -x plus 3. Now I could use elimination again, but I noticed that I have y equals -x plus 3. This is already in a good form to do substitution. So what I'm going to do is label my equations, and I'm going to substitute 2 into 1. This gives me x minus negative x plus 3 equals 5. Let's be very careful with this algebra. We now get x plus x minus 3 equals 5. So we have 2x equals 8. So x must equal 4. I'm going to take this result and substitute it into, well, I could do 1 or 2. I guess I could do either or. I'm going to choose 2 because it's easier. This gives me y equals -4 plus 3, therefore y equals -1. And I'm going to prove to you that I could use either equation. So I'm going to sub this x equals 4 into 1. And in this case, I have 4 minus y equals 5. So y equals, I'll just bring this over. So we got 5 minus 4, which gives me y equals -1. So same answer. So take your pick, just do what's easy. Now what I do want to do is a check, and here it's always good form to check in the opposite equation you have just used. So we did 2, let's check in 1. So in 1 we have our x is 4 minus our -1 equals 5, and this gives me 5 on both sides. My left side equals my right side, therefore we're good. There's my solution. This tells me my point of intersection is at xy equals 4, -1. So let's verify this by graphing. I'm going to graph equation 1 in green, and I'm going to graph equation 2 in red. Let's graph 1. In this form, I would use the intercept method. So I'm going to find my x-intercept, and y-intercept. And for the x-intercept, I let y equals 0. And this gives me x equals 5. For my y-intercept, I let x equals 0, and this gives me y equals -5. Now, for 2, I'm going to use y equals mx plus b. And this tells me my slope is -1 over 1, and my y-intercept is 3. So I'll graph that. My y-intercept's at 3, and I can now think, all right, my rise of the run. I'm going to rise -1, so I'm going to go down, actually, 1, and then 1 to the right. 1 down, 1 to the right. If I go the other way, I can run to my left and go up 1. Run to my left and go up 1. And you'll see I can carefully graph this. Now let's consider the graph of our other function. We have our x-intercept at 5. And we have our y-intercept at -5. So I could do my best to do a straight line here. And you notice there's my intercept. And it's at 1, 2, 3, 4, -1. And as you can see, that's the same as my point of intersection I found using the substitution method.